Hi, everybody. My name is Phil Gervasi. I am one of three directors of technical evangelism at Kentik. I focus primarily on the enterprise, or what we call enterprise networking, which we do differentiate somewhat from service provider. But as Justin said in the previous presentation, we do understand that we're talking about packets and very, very similar technology. So what I'm going to be talking to you about today is the underlying philosophy of Kentik, which is a data-driven approach. I'm going to be talking to you a lot about the variety of telemetry that we collect, the volume of telemetry that we collect, why we do it, what we do. And ultimately, this data-driven approach is the heart, is the foundation of network observability. Now, Justin, again, also mentioned in his presentation, might be a architecture term at Networking Field Day 29, which I think, Steve, you were at, so I remember seeing you there. I try to disarm that and say, hey, this is the difference between traditional visibility, you might even want to say legacy visibility, and then what we call network observability. So I'm going to take what Justin said in the corporate intro, and I'm going to unpack it a lot more. I will talk about machine learning a little bit, but I'm going to say now, as a fair warning, that it is just one tool in a great big toolbox of tools that we use to solve a problem, which I'm going to unpack for you, both in a problem solution statement. So I've been a network engineer for 12, 13 years, 14 years, working in enterprise, working with routers and switchers and closets and running fiber and cutting my head once on a Nexus 7K because I was getting up from plugging fiber in, cut my, you know how the tops go up like this on them to cover all the ports? So I got all the scars and all the war stories as well, and now working in observability for the past couple of years. I want to start with a question, maybe a provocative question. Does anyone really care about the network? Jody, I know you care about the network. You and I love the network. Yes, you do. I know you do. Kevin, I know you care about the network. I know what you do for a living, Kevin.
Not even close. Good to see you, Phil.
Yeah, you too. You as well. But I know that we all care about the network because we're a bunch of nerds. We're engineers. It's like, oh, wow, check out my access list. Man, that's really clean. But the reality is, that's just us because we're a bunch of nerds. People out there in the rest of the world, like my wife, my kids, my neighbors, my neighbor's a cop. He doesn't care about the network. Just like I don't really care about the plumbing in my house per se. I just care about the water coming out, right? What do they really care about? It's the services they're getting, usually in the form of an application. I actually did a podcast, a Telemetry Now podcast, go check it out, with Tony Afantis, some of you know, and he actually corrected me and said, it's not even the application necessarily that we care about, it's the data, and the application is just a conduit to the data. So interesting point that he made, but it's not necessarily the network that people care about. The network is the substrate, it is the mechanism that is used to deliver the things that we do care about, the application. And so network observability, among other things, and I'm going to be defining it explicitly, but also in these grander terms, is concerned about what the network is for with delivering application, which is why we want more and more data. It is a data-driven approach. We want context. We want very quantitative context, real metrics, MELT, right? Metrics, events, logs, traces, all that stuff. All the different information from flow and packets and eBPF, excuse me. We want all that stuff, but we also want some of that subjective information. A friend of mine and I did a podcast recently where we talked about security alerts coming in. This is not into our organization. He's just a friend of mine, works for a cybersecurity company. And he told me about how their level 1 SOC engineers, their security operations center, has to deal with this flood of alerts that come in, and about 85% of the alerts are false positives. So there's a human component of deciding whether something is meaningful or not. How do you add that to a platform so it's done programmatically? That's one of the goals of network observability. And so ultimately, the network, as much as we like to talk about speeds and feeds, it is a huge determining factor of an end user's application experience. Why? Because, 80% of the applications that I use day to day are delivered over a network. I have like 3 applications on my computer that live locally, like Adobe Premiere and Camtasia and like 2 other applications, right, that I use regularly. Almost everything is delivered over a network. And so, yes, we can do code review. We can look at infrastructure stuff from like server logs. We can say, you under-provision your VMs. It's not a network problem. Cool. But the reality is that a lot of application performance, the digital experience of people, digital experience monitoring, if you've heard that term, is dependent on the network. And so we have a unique position as network engineers to say, hey, we're not doing APM at Kentik. We're not an application performance monitoring company. But my goodness, is there a ton of application performance information embedded in the network? So what I'm going to be talking about is not just, hey, utilization on this interface. No, it's what does that mean? Why do I care? How does it affect an actual human being on a phone, on a tablet, on a computer? And if it doesn't, do we care about it? Maybe we care about it over time because of the trend. See, there's all this subjective component. It's hard. It's hard stuff. It's really interesting stuff. Now, I'm not a data scientist, but I do talk to our data scientist a lot. And about this, how do you solve these problems in math? Because what we do at Kentik is not magic. It's not magical. It is literally like Python, columnar databases, Jupyter notebooks. We're a SaaS company, so we are doing this in our own private cloud, and our customers consume that over the internet. And so ultimately, that's kind of the impetus here. What can we do with all of this data, this telemetry, to make your life better as an engineer? Ultimately, what is your goal as an engineer, though? So let's talk about that. I put this out there on Twitter, I don't know, last January. What is the date? If you're a network engineer running a network day to day, what do you care about? What do you want most from your network? Well, here's some of the answers. I think some of you know Lee. Lee does not mince words. Stability above all. That resonates with me. This person writes reliability, visibility, self-healing. That reliability and visibility part resonates with me as well. Some of you know Sean. His answer was reliability, resiliency, and then reliability again. Have you seen a theme yet? This individual says reliability, there's nothing worse than getting a call at 2 a.m. Amen. Ian, I've been interacting with him lately online. From the network, reliability. From the vendor, documentation. I'm going to focus on the reliability part for now. Our own Lexi says, honestly, does the answer ever not include reliability? I don't know. What do you think? I know what you wrote, so I'm going to assume that you agree with yourself. This person, Nicholas, says, data, I want to see the bottlenecks. And of course, you can imagine if there's a bottleneck on your WAN links, it's going to adversely affect application performance if all your applications are coming in from over the WAN.
Maybe even reliability.
Maybe even reliability, right? So this person says visibility. I don't know what's happening. Then I want to know what's happening before there's an outage, before it really hurts application performance. This person says performance, predictability, and reliability. And there's how did that get in there? No. Ignore this slide. Moving on. So what do network operators want from their network? What do we want? I've been a network operator, both for VAR and for large enterprise. We want a reliable, stable network that provides great application performance, insofar as the network is on the hook for great application performance. Because again, we're not an APM company doing code review and all these other things, so we're focused on the network component of that application delivery.
It's interesting that the trending wasn't in there so that you can do, our traffic changes over time, it grows, and you need to,
You're speaking to my heart and soul here. Of course I'm going to be talking about trending, but not only trending, seasonality and benchmark and baselining, all terms that we kind of use synonymously, but are different things. Yes.
And alcohol.
I'll be talking about that. Anybody know what that switch is?
Oh, yes.
What is it?
That's a 6500.
That is a 5500.
55.
That is an old switch.
Way back.
I just found this on the internet using, my WAN connections, getting data in the form of images. You see, it's important. So what is the network today? That is a question that is very important, because if we're talking about network engineers looking at all these things that the application relies on to get from point A to point B, anything involved with packet forwarding, and then of course the network adjacent things that are involved with packet forwarding that aren't necessarily forwarding packets, that's what we're concerned with as network engineers. So the roles are kind of changing. I didn't listen to this podcast, but Justin mentioned a recent Art of Network Engineering podcast where they discussed how, so many cloud engineers were like 2 years ago network engineers, and here they are. And you're looking at different things. You're looking at container network monitoring. You're looking at public clouds. You're looking at how do I get more information from my SaaS provider, because Microsoft 365 is not doing well and everything looks fine on my end. So how do I figure this out? My users are complaining to who? Me. Or at least our help desk, and then they're escalating to me. So, we're still interested in campus. We're still interested in switching, routing. We're still interested in the WAN, whether that's traditional BGP or SD-WAN today. We're interested in anything that the application relies on to get to you. Data center, we're interested in that east-west traffic, the public internet. which is awesome because Kentik has a unique position, and we collect as part of our telemetry global routing tables. We are a service provider where we help service providers around the world, so we have a tremendous amount of information about what's going on the public internet as well. So then we can start to say, yeah, the problem is not with your network, Steve, or with your data center, or with so-and-so, but look at this ASN and the latency that we're seeing right there. We don't know the specific device. We don't have that kind of visibility, but we know it's right there with this provider, and this is the latency that you're getting. Load balancers, DNS, IPAM, public cloud containers, all of those things that are involved with application delivery. That's what we're concerned about. And so what happens is we end up with two kind of big pillar problems. Here's where we're starting to unpack the problem that Kentik has observed, using that term, pun completely intended, using that term observed, right? We're observing this out there in the industry, specifically among network practitioners. Those are our people. And these are the problems that we face. First is in a tremendous volume of data when you collect all of this stuff, right? We collect all the traditional information like flow and SNMP. Now we have Cloudflow logs, but also using eBGP, eBGP, I keep doing that. Using eBPF, we're collecting metrics from information from container networks, so from your Kubernetes instances. We're collecting the results of synthetic tests, all of this stuff into this one giant database. Now, the whole idea of like big data and stuff, that's not necessarily a problem per se. People deal with a lot of data. The problem here for network engineers is I need to query that database in real time because I have a problem right now. I have a problem right now, and I need to be able to query it using all these different filters so I can figure out what's happening. So that's a problem that we're identifying out there. Why? Because of disparate databases. There's 712 tools. I got a flow tool, an SNMP tool, a synthetic tool, literally a standalone synthetic testing tool. And that is causing the process of troubleshooting, of managing a network to slow down. And then if you just look at the types of data, now that's a small font because it's a lot of stuff. And that's not an exhaustive list. We're always adding it. But I want you to understand the philosophy of Kentik is data-driven. So as new types of telemetry come out that are important, that we care about, we'll add it. In so much as we have engineers in the back end with the cycles to do it. But we're going to add that if it has value. So we care about that core database, unified database, eliminating this thing of disparate tools, specifically so we can do interesting, meaningful work with that data set. And so now you as a human engineer don't have to sit there logging into 9 screens to figure out how do these two different types of telemetry compare. But the type, I want to get back to that. Think about the type. That's a problem for data scientists. So you have a GeoID, right? Okay, that's whatever kind of format. You have a flow, so you have these flow records with all this information in it. You have DNS information. Maybe you have metrics from eBPF. All of these things are very different types of formats. You have millions of bits per second over here. Over here you have a percentage, 67% of your traffic is HTTPS. Over here you have a security tag or an application ID, right? That's literally, it's not a quantitative thing. It's a subjective, like it's just a random tag you used. How do you compare that in math to do that cool, fancy machine learning stuff? Well, there's an answer. In machine learning preprocessing, you have normalization, scaling, standardization, all these things that you can do. So that's a problem in and of itself. Because again, you as a human being, Jody, how do you compare these things really fast in real time to figure out how does this flow and how does this SNMP trap and how does this packet capture, how do these things compare? Literally like right now because we're under a DDoS attack.
There's a lot of guessing involved.
There's a lot of guessing involved. And who was it in NFD 29? What was her name? She said clue chaining, which is actually a term I never heard before, but she talked about how this whole issue and problem of clue chaining, that's what we do as engineers, isn't it? We kind of follow these clues and then eventually we solve the problem because that's what engineers do. And that's one of the things I love about our field. I love solving problems and building things and fixing things. But when you have 857,000 end users and the C-level all on your back saying, I need it fixed. I'm glad you're enjoying yourself, but please, I need this fixed now. We need to expedite that process. Traditional visibility tools, you could call them legacy visibility tools if you like. They are not going to solve the problem because you're talking about point solutions with disparate databases. So it's still up to you as an engineer trying to compare and contrast this data to figure out why my application stinks. Why is this interface hosed? Why is it at 99% capacity when I didn't expect it to be? So it could be those mundane things. Why is an interface shut down when it shouldn't be? But it could be also those much more complex things like why is my Northeast region having a difficult time with this application from Azure, right? And so then you end up with gaps and pockets of visibility. So if you can imagine, here, let me give you an example. Last night, I'm sitting here at the hotel lounge area. We'll call it a bar area. I was at the bar. And there was a couple of guys in front of me troubleshooting an SD-WAN problem. There was a couple of guys behind me talking about a security problem, talking about PCAPs, and it was really awesome because I'm like, these are my people. But in front of me, these two guys are talking about an SD-WAN problem and a site local here in the Bay Area. I don't know what vendor SD-WAN. They're trying to get to file shares in Azure over the SD-WAN, SMB file shares, by the way, which to me boggles my mind. Like, what? Okay. But anyway, that was what they were struggling with. And they were like, okay, one guy, I don't know who they were talking. They both had earbuds and they're talking to different people, I think, because one was talking about Azure stuff, one was talking about SD-WAN stuff, then they were talking about provider stuff. And basically the issue was, I know what's happening right here on our site in the town here. I don't know if Sunnyvale or Santa Clara, I couldn't remember what he said, but they knew what was going on and they were clicking around, right? They were experimenting. And then he made the comment, this is only happening at this site. And then somebody else is like, yeah, I'm looking at the resources in Azure. Everything looks correct, looks fine. And they're talking to somebody else like, well, I mean, who's the provider there? And immediately I'm like, gap in visibility. See, they know what's going on both ends, but there's a gap in visibility. You can get really granular if you have great visibility into those two ends too. I could say, hey, I made the request. I have a timestamp at this exact time. And I see what the server response time was when it received that request. It took, this many milliseconds. It's within threshold. I know how long it took to process. I see when it left the interface. You can track that down very, very granular. And then what we can do at Kentik is identify literally which ASN in the path is where your latency is occurring. So that's the kind of thing that you don't get with disparate visibility tools easily. Again, you can do it. So if you have a staff of 100 data scientists from MIT, you could probably get away with doing some of this stuff that way. But again, it's manual, slow clue chaining. And you can see my last bullet there. We want to avoid that. We want to get away from this human activity of root cause analysis, forecasting, and troubleshooting problems. We want to do this as programmatic as possible. And it requires doing some math on the back end and having a unified database or a UDR, unified data repository.
So one of the things that we've been talking around as delegates is as you position Kentik, as Kentik moves into the enterprise, this is probably my third or fourth presentation to sit through with Kentik, both in person and now, virtual and watch as you guys have pivoted towards enterprise. Where do you see Kentik being positioned? You have all these sources of data, you have all these things you're looking at. Where do you see Kentik as positioned as far as, is it moving towards your traditional monitoring and observability platforms, or is it still trying to stay in a niche, spot? Are things like Wi-Fi going to be involved? Like where, I'm trying to get a feel for where Kentik sits as it moves into enterprise and moves beyond just a peering analytics platform.
Yeah. Well, peering analytics is still a part of what we do. And so that's going to be part of it. Yeah. But because we have this UDR, this unified data repository, that's the key here. And so the manifestations from that, how that actually manifests itself in the industry will change over time. It's iterative. So as we see network engineers looking at traditional campus, like you mentioned, I mean, not necessarily wireless, as Justin mentioned, that's on the negative roadmap, but things like that on the campus, east-west traffic in your data center, what's going on branch to branch, which you don't see as much now. Yes, we're absolutely moving into that space, doing eventually just having your dashboard that you log into in the morning after you get your coffee and you sit down at your desk and you throw one of those screens up in your NOC and doing that kind of like, this is the beginning of my day, where are my problems? Absolutely. So that's part of a learning and monitoring, but that's just that surface like monitoring kind of dashboard. What we're doing under the hood is we're joining all of that data so that way, as soon as there is a problem, first of all, we can alert you if there is a problem before you know it, or you can continue to drill down into that problem in a unified database and filter exactly the way you want. One of the things that our CEO says, Avi, he says, be able to ask any question of your network, but he also says that he wants to provide an unbound ability to explore. So we have this twofold thing, and this is for enterprise, where we give you unsolicited insights saying you have this problem occurring, you might want to look into it. But also, when you do look into it, you can filter it any way you want. All the data is here. So that does apply to both the enterprise and the service provider for sure. And we do also look at things like transit costs and cost for AWS. So things that providers would be, or rather service providers would be interested in, things that CDNs would be interested in. So we have that OTT analytics component. We're also looking at things like just peering relationships. What is my cost to go through this path of ASNs? And though we say that service provider, we want to be able to join that data with our enterprise-focused component because that is part of the application delivery. So we find out that from our Singapore data center to our West Coast or whatever, application performance stinks, and we're able to identify, oh, it's because of this ASN. Now, as we're moving forward, you're going to see in like the demo, in the menu, everything is in one place. So you're going to see some menu items that are very service provider oriented and some that are very enterprise oriented. And moving forward over the course of 2023, you're going to see more items directly related to enterprise networking, campus related stuff, not just purely like what does my BGP peering relationships look like. Does that make sense?
Yeah, it does. So clarifying question, is it fair to say that this is that coalescing all of that data and then being able to establish relationships between the data of all the different observability sources is the gap that Kentik is filling in the enterprise market, whereas in a traditional monitoring solution, you may not have the ability to create, you can see some of the data, but not be able to create those relationships or search on those relationships. Because to me, that's what it seems like. Is that a fair take?
Sure. Yep, 100%. And I would say, if you notice the screen, I sort of speak to that, don't I? Traditional visibility, it lets you see what's happening on your network. It's more you could see more without the context. Network observability is going to do those things, whether it's a data science backend or database architecture decisions, whatever tools we have to do to get there, to kind of give you that context and understand why something is happening. Some of it's going to be programmatic. We're giving you an unsolicited insight saying there is something that is trending in this particular part of your network that you should pay attention to. You can ignore it. And so that is a main differentiator between legacy visibility or traditional visibility and then today what we call network observability. Now, the idea of observability, though, is that you don't make any changes to the system. You're observing what's happening. It's production traffic. It's end user traffic. So we do also add a non-observability, traditional observability component, which is the active monitoring that Justin said. Active monitoring being literally adding traffic to the network to test something. And the reason we do that, again, is so we're not relying on production traffic. We're not relying on angry end users to see if an application is loading slowly on somebody's computer. So we have that component as well as part of our network observability philosophy.
Yeah, I think that's an important point in the transition from service provider to enterprise. As a service provider, we can't stick traffic on a circuit we're selling to somebody else. I mean, that's, they're buying that circuit for their own traffic. But in the enterprise side, I do have that option to insert traffic and proactively look at things.
Well, we do have some customers that, service provider customers that have like their POPs in a full mesh on our screen doing basic synthetic testing, whether it's just IP addresses, pings, things like that.
Right.
So there is some value there.
It's not on a customer end-to-end circuit.
Yeah.
I cannot insert traffic on a customer end.
I will agree that a lot of the direction of our current synthetic testing, we just call it synthetics at Kentik, by the way. I don't know why we dropped the testing, but a lot of our synthetics direction is geared toward the enterprise, specifically like DEM, so doing transaction testing, page load tests. How is this application performing and from a particular agent simulating an end user? So as a quick overview, network observability, what are the goals? Justin made a comment.
It's on here. I was trying to refer to the previous slide, but you moved on too fast. I got a question.
This slide?
I was triggered on the why. Do you also validate configurations and try to deduce the intents of the network configs?
So I think
if you don't know the configuration, it's kind of difficult to determine the why something is happening.
Yeah. Well, when I say why, what we're doing is looking at why is this interface hosed? Why is the application late? Why is the network latency on this particular flow so high? So things like that. But bringing in like the business intent, bringing in, so you can of course add your hard thresholds and things like that, and that's adding your human element to saying, I have an application that my ML model will say is looking fine, but I know it's an imaging thing for an MRI, and I need my latency to be very, very low at like sub 30 milliseconds. Fine, you can set those kind of hard thresholds. So there's an element of adding that business intent there from a human being's perspective. But as far as like grabbing configs and having a golden architecture to look at and compare it to, saying, here's how I configured the network and I expect it to look, and this is how it's working right now. Are we taking CLI in? Yeah, we're not looking at CLI yet, but I think those are all things that we're thinking about. How do we now do that programmatically and add the subjective component? So that's a good question, a good point. In fact, I'm going to bring up the subjective component of what we're doing a little bit in a couple slides.
We do a bit in the cloud right now too.
What's that?
We do a bit in the cloud right now.
And we're doing a bit in cloud, yeah. So Ted will talk about some of that.
And one more thing on the why then too is, you've mentioned where your boundaries are. Like you're not looking at the Wi-Fi, and you're probably not looking at things like CPU or other things on servers. And so when you see a problem, but it's not within the bounds of what you're looking at in the network, are you able to say that what I'm monitoring is good, but the problem exists, or will you not see the problem at all?
Well, there are certain things that we can infer. So if there's a very high server response time, for example, we're going to say, why is it taking so long for that box to respond? And you can start to investigate and find that it's underutilized. The CPU is at 99%. Some of those metrics we do collect, though we're focused on the network, being, again, network observability. So what is going on in the network that's affecting the application performance? So it's going to be a little bit.
So what do you do when you see there is a problem, but you can't see why because you're not collecting the information that tells you?
So we're identifying the problem, but we don't know exactly why. As far as what's under our purview, I don't want to use the mean time to innocence, Steve. You're kind of putting me in a box here. I don't want to say it, but you can determine that it isn't a network problem at that point, right?
But that doesn't help me fix the problem.
I agree, which is why I didn't want to use the term mean time to innocence. I don't like it. I've been on those teams where you're on. At those days, it was a WebEx, right? There was no Zoom. And you're all talking about it. And it's not just a bunch of network engineers and like, pings got through, I'm out of here. I was on that WebEx for the additional 3 hours, working with the application team, working with the Microsoft team, working with the server team, trying to figure out what was going on, as a team. So as far as we're concerned, though, we are focused on the network piece of that, yeah. Which again is growing in complexity, which is why we're focused.
The initial question, though, is suppose the network is not the problem. Mm-hmm. Are you going to see the problem from the depending? There's a performance problem on this application.
Certain types of problems, yeah.
Okay, so you will see the problem. So you've seen the problem. You can see that it's not the network. Mm-hmm. As a problem. What's the alert look like? What information do I get to work with my team to find it?
So if it's like a slow page load, right, on a screen, we'll get an alert that it's taking longer than we expected based on previous page loads or our hard threshold. So we'll get an alert like that. If there's high latency in the path or something like that, which we know from inference will affect application performance, we'll get an alert from that as well. So we know that there's a problem with performance. But again, in a network context, does that?
Okay, so you will deliver the reason you think it's a problem, and from there the team can start to make inferences on whether it's the server side, the client side, or some piece of a network that I'm not monitoring.
Yeah, that's exactly right. And one of the things is that the idea here is that we are trying to eliminate as much as we can on the network side, and that does expedite the process of analysis.
Right, but there's a boundary to it.
But there is a boundary.
We're monitoring.
Yeah. And even within the network world, right, and network adjacent, we're not monitoring absolutely everything.
Right.
We're continuing to add to what we ingest, and I'll talk about that because some of the things that we ingest are actually, I guess you'd call metadata. We call it enrichment, right? And so those aren't hard metrics necessarily. So we are looking for new ways to add more context to the data so we can do those things and find and infer visibility. And again, in the whole process of root cause analysis and make that programmatic.
Right.
So our goals then with network observability, and I would say across the industry, but I know for Kentik, our goal is to provide you with useful, insightful intelligence, and insightful is in bold. Now, I use this example at NFD 29, so if you haven't seen that, go and watch that, because I give kind of a half-an-hour overview of network observability, similar to this, with a little bit of a different track. But the example that I use about insightful intelligence is, let's say that you have a 40 gig link, and it's running at 1 meg per day every day. It's a standby link. I don't know, whatever. It's just not running that hot. And then it jumps to 2 megs, which is a statistically significant increase, but it's literally irrelevant to application performance, to your end users noticing. It doesn't really mean anything. And then it drops back down to 1 meg. Is that insightful if we send off 172 alerts to you and you suffer from alert fatigue? Not necessarily. But what if that starts to go up to 2 megs, then maybe 3 megs a few days later, then 4 megs, you start to see a trend? It's still not really affecting application performance. It's probably not affecting it at all, but there is something to say that, we are seeing a trend, and hey, you should go take a look at this. This is something that could be a problem. And so that's where network observability differs in legacy visibility tools, in that we are doing some of that programmatically, automatically, but of course you can add your own manually configured thresholds as well. But think about it. When an interface goes down, you get an alert from whatever it happens to be, SNMP, whatever you're using, and you get we got a red on the screen, we got an interface down, the router's down, the switch is down, fine. But what if there's just no flow going through that device? You don't get any alerts, you don't get any down, but you expected it. You usually see this much traffic, and now we're seeing just a dribble. Very little out there is going to tell you, well, you have a problem. And so what we do at Kentik is programmatically baseline this information and benchmark what it looks like in this day, and then on this day, that's different. That's actually seasonality, not trend analysis, and say, hey, you should take a look at this. This could be a problem. Now, again, it could be a problem. So how do you add the subjective component of what's meaningful, what's significant into literal math? And that's something that our data scientists are working on. That's something the industry is working on as a whole. And you can see we're going to automate root cause analysis in as much as we can with a high degree of probability. Because when we start talking about statistical analysis and ML, you're starting to talk about correlation. We can correlate anything. It's not hard to correlate things. It's really hard. They're like correlation coefficients in math. But ultimately, what is difficult is identifying strong correlation versus weak correlation, causal relationships, and that sort of thing. So with that, we're also able to infer visibility because we're collecting so many metrics. We're able to say, we have this from your SaaS provider, and we see that their response time is this much from your request sitting in your branch office, whatever. But we see all these other paths in between. We see maybe you're backhauling to a security stack, so we're able to analyze that in your data center. But we're ultimately able to find places where we're not able to collect a telemetry, but by process of elimination, because we have so much volume and variety of data, we can sort of narrow down where the problem is likely to be, again, based on probability. And then we make, like the last bullet, predictions of potential issues, trends, seasonality. Sometimes that's programmatic, where the system is doing it for you, and I'm going to show you our insights function in a little bit, and sometimes you're setting those benchmarks yourself. So ultimately, I hope that you see, I've sort of developed the problem for you and how we're solving it, but ultimately, we're solving a network operations problem, right? We are augmenting, what we're doing at Kentik is a data-driven approach that we call network observability to augment you. So it augments you, Chris, as a network engineer running a network, helping you get to a resolution faster and figure out what's going on, why your application stinks. Or it doesn't have to be an application, but most of the services that we're delivering are applications. So I use that term kind of, it's ubiquitous. So how do we do it? This is where I'm going to get into it a little bit more technical, and I am going to address your questions in a couple slides. We ingest a huge amount of data from a variety of sources. I think that goes without saying now, right? This far in the presentation. How do we do that? I'm going to get into the platform in the next slide or in 2 slides. We're going to classify cluster data. We're going to group data. We're going to scale data, normalize data. This is all machine learning terminology. But again, as a reminder, we're not like saying ML is the silver bullet. That's just one tool of many tools in our toolbox. We are also very much focused on database architecture. How can we query the database as fast as possible so that the tool is actually relevant to you and you're not sitting there looking at a spinning wheel for 12 minutes because you want to be able to filter based on whatever you want to filter on. So we need to be ready for that. We're going to recognize patterns in data. I think somebody, I don't know who it was, asked a question about DDoS. Maybe that was Kevin. We know what a particular botnet looks like or a particular DDoS attack looks like. We have threat feeds that we're ingesting as well. And so we can say, this looks kind of like that's happening. So we're able to say, there is a potential DDoS attack happening here. These are the IP addresses involved. Would you like to kick off a mitigation? And we have processes around that. We're going to automate baselining. We're going to perform anomaly detection. There is a potential for false positives when we get into that. And so that's something that we are very focused on, making sure that what we're delivering to you is useful information, insightful information, and do some correlation to see how things relate to each other. So it's all about data for us. No, not that data. No, I'm sorry. How did that? All right. Anyway, it's all about data for us. So we start with ingesting as much data as we can from a variety of sources. What we're doing is deploying a lightweight agent Linux package, whether that's a private package or rather a private on your at your location. Private agents. We also have global agents around the world, so we can monitor activity and then add that to our overall database. So it's not necessarily your network, but cloud providers, things like that. We're going to collect from devices. We're going to collect from network adjacent things like DNS information. All of that stuff is going to come in. We're just a secure TLS tunnel into the Kentik cloud or whatever we call our platform today. But ultimately, we are a SaaS company, so that's coming into us over the public internet in a secure fashion where we can do the analysis for you and present it on our dashboards. At that point of ingest, that's when we do a lot of that statistical analysis. That's when we're going to group data. That's when we're going to classify, do whatever ML models that we're going to apply to it, because we found that that's the most efficient time to do it. If you're doing something like that later on when you're running a query in what we call Data Explorer, that's the specific function, by the way, where you get to explore all your data in an unbound fashion. If you're doing it there, it's going to be a much slower query. So we're trying to group data, give labels to unlabeled data right at the point of ingest or thereabouts. And that's also where we're going to add a tremendous amount of metadata. Now, on the bottom of your screen, you see GeoIP, Kentik Global Threat Label, whatever. You're going to see a bunch of stuff there, but ultimately, it's a lot of information, and we're always looking for more. So information from, your IPAM, or I mentioned DNS, or GeoIP, or threat feeds. We're going to add that as well, and we're able to say, this is what's happening as far as this botnet brewing in this part of the world. We're going to see, and we see your interfaces behaving in this sort of way, and we're also, so you're starting to put this puzzle together, or we're starting to put this puzzle together for you, and then we'll throw off an unsolicited insight. We call it an insight. And then that gets sent off to be stored. And on the bottom, you can see to your action triggers, you see Slack, ticketing systems, things like that, so you can take action. So that's kind of how the platform works. But I don't want you to focus completely on the ML part. That is one piece. We are using columnar databases because we found that really works with the type of security requirements that we have. It allows us to query the database very fast. So you're going to see when I do a demo for you and I'm just saying, hey, let's check out this SD-WAN thing. And I click on some different filters. There's the information. It's pretty quick. So speed is important. So some of the examples of enrichment, this is the type of data that we'll add to the database beyond that which we're collecting just from you: geolocation, routing table information, application tags, DNS information. Now that we're looking at container network monitoring, we're going to use eBPF to collect metrics. That's going to be added to the database, but also pod names, processes, process IDs. We have synthetic tests running, which again is not technically observability, but we're adding that information to the database so we can know this is how long that website is taking to load in my New York office, and not based on user information. So that's what is that? That's called the page load test in ours. We're also able to simulate an end user using the transaction test, where we're able to log in and do some stuff on an e-commerce site and see how much each individual component of that activity takes, and we'll take screenshots along the way. It's pretty neat. Our service providers will use this to monitor transit paths, so they can compare that with cost and what's the cheaper path. They're using it for their POPs for like a mesh test to look at latency among different POPs. One of the things that we've noticed, though, as far as on the enterprise side, is that we're not seeing as much like branch-to-branch traffic. We're seeing a lot of up-and-out traffic. Yes, there's east-west and data centers still, but we're seeing a lot of up-and-out traffic. I don't know if you agree with me or not, but it's not like this, I'm going to deploy this full mesh WAN network with IPsec or SD-WAN today or anything, and everybody's like, I got my print servers on this site and then my DNS servers are. It's not really how it works today. It's very much up and out and these autonomous individual sites. So we're very concerned with that internet traffic, and that's why a lot of this enrichment is very important.
Looking at this, I think from what I've seen in the industry, there's really kind of two approaches to observability. One is really focused on state information, and the other one is based on traffic information, right? Flow data, which obviously is the direction Kentik came from. And you're adding all this data to flow data. I'm wondering, and I saw BGP or routing tables were in there. Is there other state information that you're pulling in? I mean, things as simple as interface state, but maybe also, other more traditional monitoring things on physical hardware or in the software of the routing OS that you're adding in, or is it really just metadata added to the flow data from other sources outside of the network itself?
Yeah, that's a good question. I think I agree with you too. I am seeing some organizations out there looking at creating models of networks and things like that. And it's good stuff. It's really interesting to me. But to answer your question as far as what we're adding, we'll add anything we can ingest into the database that is relevant and important. So, just information from SNMP is as mundane as that may sound, is still very valuable for interface status, CRC errors, and things like that, dropped packets. So we'll ingest that to know simple things like you said, up, down, and that sort of thing, because that's still important, especially if you're logging into your NOC in the morning. You want to know what sites are having trouble. I'm going to show you in the demo something we call Kentik map, where you see a map of your sites, and including your cloud sites, including maybe a data center or branch offices, and you see that there's a little red thing. Let's go drill down into that. And then from there, you can drill down further and further all the way into the actual raw database if you wanted to. Does that make sense, Chris?
It does, thank you.
All right. So we're going to recognize patterns in the traffic, in the data as that's being ingested. We're going to incorporate domain knowledge, which is our way of saying enrichment. We're going to add more stuff that's relevant to you. It might be relevant in the sense that it's specifically your business. So, the business unit things and tags and usernames and things like that. We're going to classify new data as it comes in, because a lot of it is unlabeled, which is getting into clustering in the next column there. You can imagine that kind of 4-quadrant scatter plot graphic. We're starting to say, hey, all this data, they're all related to each other in this way. And this is done in math. It's not necessarily groundbreaking, but we're doing this now in networking, whereas 10 years ago, it wasn't necessarily done in networking. So it's not like machine learning was just invented. I worked with somebody once who has a PhD in machine learning, and he's older than me. So he got his PhD a long time ago. We do things like data reduction. Once that data is grouped, we're classifying it, labeling it, and grouping it. Now we're able to treat it like an object rather than lots and lots of data points, which is one of the ways that we're able to make querying data faster. Because again, it's not necessarily about the ML, it's about, are we able to solve that problem for you? And are you able to query the database quickly? Are we able to give you meaningful insights, or is it just another alert fatigue? We use a variety. The time series models, that's a family of ML models. There's a lot under there, like linear regression, autoregression, things like that. And we reserve the right to change our minds. I think, Steve, you mentioned that earlier. So when something isn't producing the results that we want, we will do something different. It's really not about the ML, it's about the results. It's about, are we giving network operators what they need to solve problems faster? And so we'll use a variety of time series models to estimate seasonality and trends, to do forecasting, to detect anomalies and things like that.
This all sounds great. I know you were getting a little bit granular here, but I have like a higher level overview type of question for you. So one of the words that I haven't heard yet is simple or simplification, right? You have a lot of data coming in. You're talking about a lot of features and capabilities, and that's great. But all of that can get very overwhelming for a user. And I'm curious, is there anything specific that Kentik is focusing on to simplify this platform? Because, making the user experience as simple and easy as possible, that tool is only going to be as good as the user who ends up using it at the end of the day, right? So I'm curious, we have a lot of things that we're talking about with time series models, clustering, making sure all the data comes in and is correlated. But how are you actually making sure that the user can understand how to use this pretty quickly and doesn't need like a huge, steep learning curve to get over?
Yeah. Well, I love that question, because that's exactly what we're trying to do. So this is what we're doing on the back end. And we have literal PhDs working on this stuff. And that's not something that we would expect a network operator to do. But what this is going to do, along with all the other technology that we're doing, or rather utilizing, is going to provide you an unsolicited alert, and which you can drill down to very, very simply. Now, I do want to say that it's twofold. We're going to make it as simple as possible and say, this is happening and this is a likely cause. You need to investigate it. It's not certain, but this is highly probable. But we're also going to give you that unbound ability to explore the data as well. So you're having both this unsolicited insight, which could be a variety of things. There's no flow. This application is not doing well in this region. But it could also be the ability to get down literally as granular as you want and then filter. So I love that question because we are taking that very much to heart. How can we make this as usable as possible? Part of being usable is also that it's fast, and that's something that we're always working on, making it as efficient as possible under the hood, so that way it is not sitting there spinning while you're trying to solve a problem. That work?
Yeah,
Okay.
that about answers it. Thank you.
Okay. Ultimately, I think it comes down to, I guess, what you call the human factor, right? I think you all see the words on the screen. You know what they mean. I know what they mean. I know it's ridiculous. You know, I laugh every time I hear it and see it on Twitter. But like my kids don't. They know what the words mean. My 16-year-old, right? She knows what on means and premise means. She knows what premises means as well. But it's not funny to her. It's funny to us, though. I hope it's funny to us. It's funny to me. Because we have a greater context. There's this subjective component of experiences and other knowledge, domain knowledge, if you want to call it that, all this other knowledge that informs us when we derive meaning from these words, at least in English, on the screen. Whereas the rest of the world doesn't have that domain knowledge, that context. And so there's a human part of engineering. I use this slide at NFD 29, and I really like it. It's a popular slide. I've seen it in other presentations. But it's not a matter of just correlating data, because there's a human component of understanding. So that's what network observability is about. It's iterative. We're getting there. It's not that we have this silver bullet that literally with fancy AI, which we don't even use that term, can tell you exactly what's going on and give you all the relationships and just fix the problem for you. And you literally just sit there with your coffee. But if you look at the screen, you see, are those two items correlated? I mean, yeah, they're highly correlated. The answer is yes. But And so a system might say to you, hey, you need to check this out. Look at this correlation. You need to fix ice cream sales, or you need to, because it's causing these shark attacks. But we know that that's not the case. There is some other causal relationship, this other variable that we're not looking at, that we kind of get. It's inferred or implied, whatever you want to look at it. So there's a human part of engineering. And network observability is all about that. It's collecting this data and doing something with it so it provides you something meaningful, adding an incredible amount of metadata telemetry, or to the telemetry in order to do that. So here's an example. Oh, I missed the word repository. It says unified data. It's supposed to say unified data repository, whatever. Unified data. It's still unified. So you have an SD-WAN problem. You're gathering telemetry from your SD-WAN. But in that process, we're going to have that SD-WAN telemetry in the same overall database with all the other telemetry and metadata and enrichment and stuff from your network, stuff from not your network, from public cloud, from SaaS providers, things like that, as much as we can get. And now you're going to see that SD-WAN performance or that issue of application delivery over your SD-WAN in that context. And that's what's getting there to our long-term end goal, which is to make this whole process as programmatic as possible, where we say, here's what's happening, and this is the likely cause within this level of confidence. Go back.
So you track SD-WAN performance data, you track to some degree routing database, right? So my question is, if you notice a performance degradation in SD-WAN or timeouts, can you correlate that to, for example, an AS path change?
Actually, that's a really good, yeah, so we can see, all right.
My question too. So you're good, man. You got it, Tyler.
You guys really had the same exact question in mind?
Yeah, really. No, I was going to say the same thing. It's how do you correlate what's happening in the DFZ, because that's where Kentik started from, to something like SD-WAN loss. Like, I know I have SD-WAN loss, right? I actually have this problem right now in Africa. I have a path from Africa to London with 4 different links that are having loss, but like, I don't know why, because I don't know what's happening on the AS paths as I navigate from Northern Africa to Europe and what the DFC looks like between those two. So taking Kentik's knowledge of the DFC into that and pairing it with my SD-WAN loss is a really helpful metric to tie together. I don't know if that was exactly what Tyler was asking, but that was what I was going to ask.
Yeah, similar thing. Like I've had problems where a provider has an LDP session get stuck and it still advertises prefixes, and then we get lost over one of their links because their LDP session got stuck. And we only noticed it after an AS path change.
Yeah. This is why I love NFD. I mean, you were both thinking along the same lines in this question. And yeah, how are you asking me how we correlate that information, or if we do? I mean, the answer to the second is yeah. So the answer to the first, how we do it, I mean, that really, from a really truly hardcore math perspective, that's a question for our data scientists. But ultimately, I will say that it's not as complex as doing all this fancy math and ML. A lot of it is just in time series. That's sometimes the solution is pretty easy, but we're able to see that there were these prefixes not advertised anymore, pulled at this time, and we saw traffic shift to this transit, whatever. And at the same time, we're seeing a change in application activity, which tunnel you're taking or which VPN you're taking, if it's Cisco SD-WAN. And so in that, there is an element of probability, confidence, certainty, uncertainty. So first of all, what was the cause for that? What was the cause that those BGP prefixes were pulled? So we don't know certain times why a provider does a certain thing, but we're able to see the activity. And then, of course, what's the confidence level of that activity directly affected why I chose one tonal over another? And so the more data we have, the more confident we can be in that. So I don't know like as far as how we do that in math, I really can't answer. But yeah, absolutely we do that. But you're going to see it in kind of a time series where I can probably queue up a dashboard. I didn't prepare one for this specific scenario, but you'd see all your the data that you want to see all happening in the same time series with your standard deviation, your rolling standard deviation of what you expect and don't expect. And you can see, okay, at this time I had this much, I had this change in public internet path. And you can see that, and we can see we went from this ASN and then we switched to this peer and this happened. And then over here, I can see my application latency went very high at that exact time. And that's kind of how that works.
Don't take too much away. You're going into my demo.
I'm stealing from Ted's demo. So I assume that means that you're going to be talking about that.
I'm doing it in the cloud.
And he's doing it in the cloud. Yep. So
just to probe on that same problem a little bit more. So suppose in my SD-WAN, I have these two ISPs. They do have independent paths. I have an application that correctly worked and did not have a problem because it went from path 1 to path 2. Mm-hmm. Do I get an alert that there's a problem on path 1 so that I can ring the bell of the ISP involved and get them to fix it so I have a legitimate backup when the same problem happens on path 2? Or is that your question?
Are you going to be talking about it?
I'm not talking about that specifically today.
Are you? Okay.
That right there is my #1 use case, talking to
and one thing you can do is if you're running synthetics where you're testing your multiple paths out and going in different directions and you have your agents and you have your end-to-end, you can test and say, hey, latency over that link or packet loss or whatever you're testing, jitter, maybe you're running real-time applications, has exceeded this threshold, or it's a dynamically created threshold. So you can still monitor that without using active traffic because you're not using it, right? Your application went over the other link as it should. Right. You can still test, and that's a really good use case for synthetic monitoring.
Yeah, because that's a lot of problems we have with reliability. I mean, everybody wants reliability on their network, but when I successfully am reliable in shift, I don't always know that the other one has a problem, and so then I eventually do have a problem when the reliability goes shift back, and that's been a really thorny one to get to the bottom of.
Yeah, and what we'd like to do is then give you the answer, or at least a suggestion of this is probably the issue, again, in the realm of confidence and probability, but we know that it's not as easy as that. You're going to have to drill down. And so that's why we'll say, hey, we run the synthetic test, here's the alert that something's going on, and we make it very easy for you to then drill down in that filters that were already created to produce that alert. So you can drill down into the raw data and figure out what's going on. So we'll do both of those things, which is basically what I was talking about with Lexi earlier.
Sorry, I need to double click on that though. So the SD-WAN platform will automatically shift the application traffic because that's what it's supposed
policy,
to do, right? But would Kentik then give me the underlay issue on what happened in the underlay so that the overlay had to shift the traffic? Is that what we are talking about?
Yeah, we see both the underlay and the overlay. We don't ingest from every single SD-WAN vendor at the moment because it's something we're working on. But if you're running like a Silver Peak SD-WAN, we can see what's going on the public internet. We can see what's going on in the underlay. We can see which applications, hopefully they're pinned to the right thing. We can see all that stuff. In the data center as well, we can see those overlays as well, and we can see layer 2 to layer 3 mappings and east to west. I haven't been talking about data center very much. I actually have it on a dashboard I'll show you, but I think I went way, way, way long, so I'm going to have to wrap this up very quickly. I haven't been looking at the clock. So ultimately, we're trying to solve problems faster. If you look at the screenshot on the right, these are just a couple of example things that we'll just send to you in the Insights overview window. Hey, take a look at this. Click on it, and you can drill down immediately and follow that down into the rabbit hole as deep as you want to go. And what we're doing at Kentik is we have this constant feedback loop where we're always trying to figure out, is this meaningful to network operators? Should we be looking at a different insight? It's a constant conversation happening with our company, within our company, which is awesome. I love it as a network person. I'm going to skip those 5 bullets there and talk about Kentik synthetics very, very quickly. So Kentik synthetics, synthetic testing, synthetic monitoring, it's active monitoring. And the reason we do that is because we also want to monitor without using production traffic. So Tyler, you're like, yeah, my application stinks, and I know that because my users are mad. Well, it would be great if we knew that there were problems ahead of that. So it's not, we can simulate an end user going into a website and doing some activity and putting something in a cart, making a purchase. We can continually open a web page or various images on a web page, whatever, click on a thing and see how long that takes, and then have a waterfall of all the different components. And that there's a lot of help there for planning, for root cause analysis, to identify problems that could potentially affect user the user experience. Here are a few different examples of Kentik tests, or rather synthetic tests. We have web tests, application tests, DNS. They're varied. Some are very network centric, some are more application centric based on your needs. But I'm going to go very quick here just because of time. So I'm going to do a quick demo. I'm going to go very, very quick through this demo. So please forgive me for not camping on things that I otherwise would normally camp on. There's so much stuff to see. And we're talking about like this underlying database. So we could spend all day looking at different cool permutations and this and that, but I'm not. So what I have here, I'm logged into the observation deck. That's a popular place for our customers to start. You could create your own dashboards, but you see here, I'm taking a look at my Silver Peak SD-WAN, some information. I see my different VPNs and tunnels, and you can drill down to the traffic to see what amount of traffic is going over what link and when. Here I have my insights open because for me as a network operator, I like that. I want to know about different trends and an interface that is seeing more flow than usual or less flow, or maybe more traffic is going to AWS than I normally expect, whatever. And you can scroll through that. We have them categorized. Here I just have the 2, protect and which is security incidents like botnets and DDoS and things like that. As I go down, this is very enterprise focused. So for somebody like Kevin, you might have very different dashboards up here. It's completely customizable. Here are my pods, containers. I'm working on a DC migration and I want to see that east-west traffic. So I have that all mapped out. Here I can see on my mesh that I have some problems, and I can just say, oh, I got a yellow. So there's a critical, and I can drill down into that. Here are my individual sites. So as an example, here's my DFW, Dallas-Fort Worth. I say there's an issue, so I can view the site details and drill down into that site specifically. And as I do that, I want to say, what are the devices behind that site? And you can see all the devices there. I want to see them by maybe IP or by interface, whatever it happens to be. And you can click on those devices and drill down even further. And you can find that problem device behind the scenes. Here I have the Kentik map that I mentioned earlier, and you can see that I have a problem here. So I can drill down there. I have a problem here on the West Coast. You open that up and continue to drill down, click on the links, and we are basically showing you the underlying data. So you can drill down and go down that rabbit hole. It's an unbound ability to explore the data, whether you want to see that in the form of metrics, which you can change, and the metadata that we used to get there. Some of our customers like the Network Explorer. I'm going very fast. Here is the Data Explorer. I just have them in open tabs. So let's say I want to take a look at my SD-WAN. I can choose, let's say, Cisco SD-WAN, and I want to choose a couple of different dimensions. So we'll go down to, we'll say interface, connectivity type, and maybe VPN identifier. Leave it at that. And it's going to produce just whatever I want it to see. And you're going to start to see that information broken down for you. But there are so many dimensions, hundreds of dimensions, things that you can filter on. And so you can parse the data any way you like because it's all there. That's the point. Our Insights tab, here I have the last 90 days, and you can start going through and seeing all the different things that are possible issues that would be alerted on. So as I scroll down here, interface utilization drop. We had an interface It has less traffic than we normally expected, and you can start to drill down. This is something that the system generated for you. In our synthetics dashboard, here's all the different tests that we have. Remember, this is not production traffic, so this is not an alert that something bad happened necessarily. This is an alert that a test is failing. So this is stuff that's happening that's bad before it affects end users. And you can drill down into them. Here I have the test control center, going very fast, my apologies. And these are all the different tests that I have active. And here on the right, under filters, you can see the different types of tests. Now I have one set up. It's a page load test. It's a demo here. I'll open that up. And you can see in your time series up here, so you can then say, oh, my end user is saying there's a problem the other day. Well, I hated that when I was a network engineer. Like, really? I have to go, like, how I don't have a time machine. But here you can look at that and go back and say, oh, I have this much problem or this much latency or this much packet loss at this specific timestamp. And because we have all the other data, we can figure out why. So in this case, for example, I'm scrolling along here, and let's say right there, you can see I have a lot of latency. I'm going to go into the details from this test agent. Remember, these are test agents. And I can see, my goodness, there's problems. DOM processing time is at 6 seconds. So there's a lot of, and you can see domain lookup time is very high. So I'm going to go under my waterfall and look at that particular issue and then scroll over everything happening in the page load test. It's capturing everything. Remember, synthetic traffic that's going on. And I can see the DNS lookup. It took almost 6 seconds. What is it trying to look up? And you can see which file stalled. This bootstrap.min.js file stalled. So there's something wrong with that particular file, or DNS is not working to resolve that. And therefore, the entire application is slowing down. And your end users will eventually feel that. So you can solve that ahead of time.